And we're going to continue using the same example that we were using before. So we'll just add some things in to the personnel program or person program we're working on. Let's go. So far we've only dealt with writing and reading the string data type sequentially. Let's look at writing other data types like int, float, and double. First, we will add integer, float, and double data members and accessors to our class. So in taking a look at the person class, we're going to add a couple of data members just to give us some different data types, so that we're not using all strings in this example. Alright, so that'll give us 3 additional data types, and of course I want to write the accessors for them. So for the first one, it doesn't have to return anything for the set, but it needs to take an integer since age is an integer down here. And we'll just call it set age, and have to take the matching data type. And remember that the public data comes in on the right, and then on the left side of the assignment operator is the private data. Okay, so there's our set. And now let's do our set size. And that would be a float. Just take a float argument. Okay. And now let's do our set weight. And that is a double. Okay. And let's code our gets. Come down here. Remember, they have to return the right value, so age needs to return an integer. Doesn't have to take any arguments. In this case, get size needs to return a float. Doesn't have to take any arguments, but and get weight has to return a double. Doesn't have to take any arguments. Okay. So we just added these data members into our class here. And then let's add the capability to both enter and display those data members as well. That's the first modification that we need to make here. Let's recode DisplayPerson to display the additional data members. So in DisplayPerson, we're going to come down, and after this, let's see. Let's add that in after name, since that's kind of personal data or so forth. Right, so we need to add 3 lines of output, and we'll do age, size, and weight. Right, get age, get size, get weight. Okay. Let's recode edit info for person to edit the additional data members. Now that we've added our new data members, and we've coded the ability to display those data members from the class, we need to add the ability to input or modify, edit those data members in the enter info for person function. Okay, and before this was just straightforward, right? We just called getLine and a string, and that's because all of our data up here was string data. If you look at the class, these were all strings. So if you look at the accessor methods, they accept strings as arguments. Now, I did this on purpose. There's a little method to the madness. I chose different data types for age, size, and weight to show you that, when it's not string data, there's a little bit more to it. We have to convert the data from string to whatever data type we're going to set. So look at these data types and look up here. Look what the accessors expect: integer, float, double. So we can't just pass a string in there, right? So back down to the edit function, edit info for person. Let's do it since they're personal attributes right after name. So occupation, location, references, name stay the same. We only have to do the see and ignore once to consume that one character with the get line. After that, we can just call get line without see and ignore. But I would want to display, add a line, and age, and then I'd want to call getLine, and I want to pass in cn console in and recycle our string. So pass in temp. Now here's the problem. I want to do this cg, and I'm going to want to set age, but remember age is expecting an integer. So I can't just pass in temp. It's the wrong data type. See, it tells me it's no suitable conversion. It's not compatible. It's a string, but the accessor method wants up here an integer. We go up here. It's expecting an integer right there. Okay. So let me go. Whoa. Let me get back down here. To convert ASCII text to an integer, use the function atoi. Okay. So what we need to do is we need to have some way of converting this from a string data type to an integer data type. And lucky for us, there's a function that comes to the rescue, and that's atoi. Okay, ASCII to integer is what it stands for. And now, again, we have another problem, though. I'd love to just be able to pass in temp the string, but I can't really do that. Sure, temp is a string, and any string is an array of type character, but it's a more sophisticated type of string object, string class object, with methods and attributes that aren't there with just a simple character array. And the problem with atoi is, notice it expects a constant character pointer. In other words, it wants a simple character array. So I can't do this. But what I can do, I could come up here, I could create a very simple string, just a character array, or array of type character. We'll call it numbuffer. And we'll give it 10 elements. And if we're expecting larger numbers, I could make it 100 or something, whatever. But I'm not going to have more than 10 digits. It's just age and size and weight for a person here. So it wouldn't really make sense to make that larger. All right, so we have this now. It's a simple type of string. Now, how do we convert it, or how do we get this kind of string into that kind of string? Because I could pass this in, right? Numbuffer. Look, if I were to pass in numbuffer, then we're good. Now the problem is it's null. There's no value there. All right, so I'm going to leave temp there to remind us that we need to modify that. But how would we do that? Well, you might think that you could do this and then just set the value of temp. Oops, let me go back and add my m there. Okay, but well, you can do that with some types of strings or objects because of the copy constructor, or there's an overloaded operator. They use operator overloading. No conversion exists, no built-in conversion exists to go from a string data type, string class data type, to a character array. All right, so in this example, we can't do this, but what we can do is create a for loop. And remember, if every string, no matter how sophisticated, is pretty much just an array of type character, then we can do a member-wise copy. So we could, in the initialization, let's make a variable called x, set it out at 0 because that's the subscript value, or the very first element inside of an array. Let's say while x is less than temp, and we'll call the length function, which returns the number of characters or elements in the array. And then our update, or our action, will be to postfix increment x. Okay. And then if I were to do this, what I can do is a member-wise copy. I'm just going to use the subscript value. So on numbuffer and on temp. All right. So if we say this, then this effectively will copy character by character, element by element, this more sophisticated string class object into this more simplistic character array type object. And then remember that the name of array is a pointer to the entire array structure. So if I simply take the name of that character array, numbuffer, don't need a subscript value, and pass it in, that's the whole array. That's the string of characters, so to speak. And that I can convert to an integer. And then I can call my accessor method, set age, and pass in an integer like I would like. Okay. So let's test that real quick. And we'll build a person, enter person's info, and 42, and alright, so if I do this, and notice I can display the info. Now, we haven't initialized these yet, and that's why you see this value here. Alright, they have uninitialized values on the float and the double. But the integer here, we can see that it effectively converted our character array into an integer and was able to set it via the accessor method. And if we wanted to, we can even do some math on it. Now, that doesn't bulletproof it in the sense that, what would happen if I typed in something that wasn't a number there, or wasn't a digit? All right. In other words, we'll go to the enter person function, and and let me type in banana. All right, and all right, I'll just do that. So if I do that, in this case, you know, atoi was able to set it to 0, but there's maybe a little bit of bulletproofing there. What are we going to do? What's the default behavior if they don't give us a number and we're converting from a string to a number? So just something to think about. And to tell if ASCII text is numerical or not, use the function isdigit. One of the things you could do, or one of the functions that you could use, is one called isdigit. That's built in, and so we could simply say if not isdigit, it just returns a boolean true or false on whether something is a digit. We would say if not isdigit, and then we would pass in our character array. Just kind of make it a little bit safer. If not isdigit num buffer, and let's use our subscript value there. Single character. So in other words, we're taking each character and copying it character by character, but we could do this, or actually, let me say it on temp there. But I could look at it character by character and say, well, okay, if that's 0 through 9, that's a digit, that's a number. But if it's not, what if it's A, B, C, D, Z, whatever? And then I could just simply display something here. Let me give a little feedback. And we will simply say, we'll use what's there, we'll pass it into the stream, and we'll say it was not a number. And just to be on the safe side, setting to 0. All right, we could do something like that. And we could come over here and we could simply take that, and not the number 0, but since we're dealing with characters, before we do the conversion, we would want to set it to the actual character. All right, so that might be a safe way. There's a lot you could do, but we could use this function here isdigit if we wanted to handle that. All right, just showing you that as an example. So if I were to rebuild the project and test it, now there's a little bit more bulletproofing, or maybe a little bit more of a failsafe there. If I can actually choose to do something now based on whether or not they put a number in. So I built a person, I go here, name, all right, so I enter banana, and then banana just goes down setting it all to 0, and all right, tester, and there. So that might just be a better way, to bulletproof or to handle that. So if we needed, if we needed to provide some better bulletproofing, so we could even put that into a function if we wanted to. It's sort of repetitive there, and we might decide to do that. To keep things brief, however, I'm just going to go ahead and take this out, and I'll just try to keep things as brief as possible. So this would be less bulletproof, I guess, or less flexible in terms of dealing with erroneous input, but it'll work for us. It'll be okay as long as we don't plan on doing anything with non-numerical values. To convert ASCII text to a float or double, use atof. Alright, so this is what works for age. Now, what would we do if we wanted to get the next one, which was a float? Remember, if I come up here, and size was a float, and it expects a float in its successor function or successor method. So in this example, boy, this is easy, huh? It just dealt with all different types of data types. You can pass it into the stream operator, but here we have to be a bit more thoughtful. Well, I could pretty much do what I'm doing here. So if I wanted to copy that whole block of code, I could change it from age to size, and instead of set age down here, I want to call set size. Now all of this code is pretty much the same. All right, doesn't really change there. And again, this might be a good candidate. I could just code this into a function, since I'm kind of doing a lot of this code is almost like boilerplate code or repetitively. But another thing that would change, besides the name of the accessor function and the cout statement up here, is that instead of a to I, I'd want to call it a to f. I might lose precision. A to I would still work, but I might lose precision on a decimal value. But there's another function ASCII to float, A to F, which I can call on numbuffer, and that would take decimal values. Okay. And then with that in mind, I'm just going to copy and paste this chunk of code again and paste it. I guess that was redundant, but and this time I'm going to say wait, and instead of set size, I want to say set weight. Okay. And the same thing here, and I can use A to F. That would still be more precise than A to I, but I can do something similar there. So different data types, string data types, I don't really have to do much other than call getLine and call the accessor, but with things like integers and floats and doubles, I have to convert the data from the string data type to, whatever it needs, integer, float, or double respectively. Okay, and I won't have to worry about this when I'm saving, alright, but when I'm reading from a file, I'll have to do the same thing. I'll have to perform a conversion later on when we want to read that data in from the file and then set it to be a different data type if I were doing ASCII file access. Let's test it. Let's test the program so far. We'll rebuild it and make sure that it does what we want. Alright, so I'm going to come up here and build a person, and let's enter a person's info. And let's see, who knows? How old is she? Maybe 18. Size, 5'6", I don't know. Weight, 90.345 pounds, or kilograms, or whatever. Princess. Hyrule. And Midna, alright? So if I were to do this, let's call the display function. Notice that it maintained our precision. She's 5.6 feet tall, or 90.345 pounds, or whatever you want to call her. Alright, so that's doing what we want. We verified that. Let's recode save person to write our new data members. So now really the only thing left is we need to modify save person and load person. And we'll look at doing this in ASCII or sequential file access, and then we'll also look at it in binary file access later. So we have these, and we were going to insert these here when we write. We're using a line as a delimiter. And the neat thing about the stream operator with fstream and ifstream and ostream is it can deal with different data types. So we don't have to do much in the save function where we're just writing, other than we simply need to call the accessor and return whatever the value is stored in that data member of that class. So we'll do age and size and weight. That was pretty easy, huh? Nothing much to do there. Alright, so that would complete our save person function, and let's verify that. We'll rebuild the project, and let's go through here, we'll run it, and when we run it, and let me modify this real quick, maybe it'll be easier to see if I modify the background for you. There you go. So when we run it, we'll build a person, let's enter a person's info. Alright, so Zelda, and 18, and let's see, 5.6. What was it? And then weight, I don't remember, 90 pounds, 345 or something we said. Occupation, she's a princess. Location, Hyrule. And references would be Link and her buddy Midna there. Alright, so if we look at the attributes, those are all the data attributes of a person. Let's save it to a file. I'll hit S to save. Data was saved successfully. Let's go take a look at the file now. So if I come over here and I open the file, and let me bring it over here, notice that here we have all of our data. Right? So there was really nothing to do there other than simply call the get accessor functions on the class. Writing or saving to the file was pretty straightforward, pretty easy. Let's recode load person to read our new data members. Now that we've completed save person, let's take a look at completing load person. Alright? So we have these 4 data members that we've been reading in, and they're just string data. So we don't really have to do anything other than read it, because it comes in as string data, and the accessor method takes a string. Remember, if I go up here and look at our class, these 4 data members are strings, and we accept strings. If you look at the set methods there. The problem is, age and size and weight are different data types, integer, float, and double. And again, we're taking different arguments, integer, float, and double, so we can't just pass in string data. So we'll have to do something similar to what we did down here, where we used A to I and A to F to convert that data to the right data type. So let me go back up here, and remember, when you're serializing a class or object, you have to read it back in the exact same order that you wrote it. So if up here the order that I wrote it was name, age, size, weight, occupation, location, references, then age, size, and weight need to go right after name and before occupation. I have to maintain that order, right, or that relationship. Okay, so I read and set the name, so at this point I'm going to call getLine, and I'm going to use datafile and recycle our temporary string variable there. And I want to call the accessor, and here's where I run into the issue. I'm going to call setAge. SetAge expects an integer, so I want to pass in the string temp, but I can't. I can't convert, from this without help. Well, a to I comes to the rescue. That'll let me convert that string into integer data. However, it expects a more simplistic type of string, not a string class object. Now I need this to work with getLine, but however, this will not work with a to I. So what can I do? Same thing we did before. We'll create a more simplistic type of string, just an array of type character. Call it numbuffer. We don't really need more than 10 characters in it. So we'll put 10 characters in it. If I do this, I can do a member-wise copy with a for loop. And I'll add my open and closing braces there. So in my for loop, the initialization will be int x equals 0 to start at the first element of the array. Remember, the subscript value is 0. All arrays start at 0. And I'll say the condition part will be while x is less than temp, and we'll call the length function. That'll return the number of elements or characters stored in temp. And then the update portion of our for loop will simply be to postfix increment x. Okay? And if I did that, then all I have to do is take the x subscript value of numbuffer, and I'll take the x subscript value of temp, and I'll assign them back and forth. So member by member, we'll take all of the characters here and we'll store them here. And then what I can do now, remember that the name of an array is a pointer to the entire array structure. So even if I had double or triple or quadruple digits, all I have to do is take the name of the array itself and pass it into a to I. And then this string class object has now been converted to this type of string, a character array. And I was able to pass that into a to I, and it's able to convert it to an integer. And then all of that is then passed into the accessor method that we wrote to set age on our person object. Okay, that's something similar to what we do. And remember, we could also use I can't even say it. Remember, we could also use isdigit if we wanted to bulletproof that a little bit more. But to keep the code smaller and to keep it brief, I'll leave that little bit of bulletproofing out. So this is pretty much what we want to do for the next two, other than instead of a to I, we want to call a to f, and we'll want to call a different accessor method. So I'm going to just copy and paste this block of code for the next one. All right, and then the next one is just that the accessor method is going to be different. And in this case, we want to not age, but we want to set size, pass that into size, and instead of a to I, we want to call a to f, so we don't lose any precision on the decimal value. A to f can deal with decimal values. And we're going to do the next. I'm going to copy and paste. I want to do the next variable in the exact same way, except that instead of set size, it was set weight. All right, so set weight, and then both of these will be a to f, because there might be, and indeed there were, decimal values, whereas this is a to I, just a whole number value. All right, so these are the only three we had to convert. They're in the right order. So name's just a string. We do name, then we do age convert, size convert, weight convert, and then occupation, location, and references. We save that all to the file, and then we're all set. So we've successfully converted our our program, our project here, so that not only will it save those additional data members of different data types, but it would also load those additional data members of different data types. And let's just test it out. So let's build the project. Okay. And we don't really have to build a person since I threw that here in the load code, new person, but let's go ahead and run it here, and we're just going to say load a person. And success data was loaded, and now let's display a person and see if we got our data members. And there's our data members right there. So we didn't lose any precision. There's our decimal values and so forth. When you need to convert numerical data to ASCII data, use I to A or underscore I to A underscore S. While we're on the topic of conversion functions, here's another project called Virtual Pet that's sort of like a Digipet or a little virtual pet type game or program. So in addition to functions that you have like a to I and a to f that convert ASCII to integer or floats, you have functions that do the opposite or go the other way. And in this case, we're going to look at I to a, and I to a does the opposite. It converts an integer to ASCII. All right, so it takes number data or numerical, converts it to string or ASCII data. So here are some variables: life, age, size. I have to convert them to simple character arrays using conversion buffer up here, and this is just simply the the radix value. And when I do that, I'm going to set them on C static text controls on a form. And what that looks like is this. All right, so I'll run it, and let me go ahead and click start and enter. In this case, we'll choose a mammal, and I want a cat, or maybe I want a dog or no. I'll go with a cat. We'll just go with a cat. We'll go to Siamese cat. We'll build a cat. All right. So I'll move this over here, but this numerical data has to be converted with I to a. Well, I guess that's deprecated. Underscore I to a underscore s. How annoying is that? But that's the new and improved version. Hey, with the underscores. So we have to convert that and set that in these boxes here. Okay. And once we do that, we can display it in our C static controls. So just again, while we're on the topic of conversion or converting data back and forth from one data type to another, there's another set of functions that you can use to convert numerical data into ASCII data. And just to give you another example, here is another project. I'll go over here and let's see, right here and here and here and here, and we'll look at the ADT. Let me go into the character class. Same thing here. I've got to use I to a to take numerical data like hit points and so forth, and convert it into ASCII data that I can display in a C static text control. And I have to rebuild this project here real quick. It's outdated, been a while, but and if I do this, same thing here. So alright, and then that's these C static controls here